Hi, Kabir. Welcome back to Airhacks FM.
Yeah, thank you. Glad to be back.
And you are the master of A2A.
Well, there's several of us on the team, so we're all figuring it out together.
Mm-hmm.
And of course, there's a specification initiated by Google, but it's now donated to the Linux Foundation.
Mm-hmm.
So there's other companies influencing the specification as well.
Exactly. So, agent-to-agent protocol was initiated by Google, donated to Linux Foundation, and the A2A Java SDK reference implementation is Quarkus, which is amazing, actually.
Yeah. Well, basically, we needed something to test with in the
Mm-hmm.
SDK. So, yeah, it's like Quarkus is like lightweight. It's easy to
Mm-hmm.
bootstrap with everything.
Mm-hmm.
Wildfly is more difficult.
Mm-hmm.
And those are like the two things we are familiar with on the team.
But how it happened that Google picked Quarkus as A2A SDK, or you know the story?
Actually, this was all driven by us. So Red Hat at the time, and then IBM. So the background really is that my manager, Stefano Maestri
Mm-hmm.
from Italy, he's been really interested in AI for several years.
Mm-hmm.
So he's always looking for stuff to do in this area.
Mm-hmm.
I probably shouldn't go on too big a detour, but
No, no. Mm-hmm.
but he was working on, like, we had a colleague called Farah Juma who was really bright. She's left now.
Mm-hmm.
But her master's was in AI like 14 years ago or something.
Okay.
So she was working on all these like AI initiatives with Stefano. And then like a year and a half ago, I joined, I think, or maybe
Mm-hmm.
even before, maybe a year and a half ish. Anyway, I'll cut out some of the backstory.
Mm-hmm.
So then Stefano was like, hey, Google's got this new protocol called A2A,
Mm-hmm.
and it's like a Python implementation.
Mm-hmm.
And there was the samples directory and the specification. And in the samples directory, somebody had like committed some like initial work to get it working with Java.
Mm-hmm.
But Stefano was like, it'd be great if we could become like the Java implementation.
Mm-hmm.
So we just kind of like set off all, whatever the term is, like really
Okay.
actively started developing our own proper version of the SDK.
Mm-hmm.
And then I can't remember exactly when, but maybe last summer, around the time of the first version of the spec, which was 030, I believe, or maybe even 025. We got in touch with Google and say, hey, we got this, and
Mm-hmm.
it's working. And we also wrote the TCK for A2A.
So it is written, I guess, with Quarkus as well, the TCK, right?
The TCK is actually written in Python.
Wow.
Because our thinking was basically that like AI people really like Python, so
You also
we
like
kind of
Python?
blah.
I was just curious.
Yeah.
Okay.
It's nice in some ways, but it's also a bit strange. It has like, yeah, the core ideas are nice, but then it gets a bit weird if you
Mm-hmm.
are not an expert.
Yeah, I was curious about Python because it became popular, and I was, what interests me is how more productive or how much more expressive or shorter Python can get than Java. And what I found, I had to migrate in one project Python to Java. That actually the final Java version was shorter than Python, and from my perspective, even easier to understand. Of course, there was just simple Java code, but still. And this is why I'm asking, but maybe I missed something.
Yeah, my
Mm-hmm.
initial impressions of Python was that it kind of like encouraged me not to do good coding practices.
Mm-hmm.
But then as I got a bit more familiar, then you do have some of the same safeguards, although they're more like by convention rather than the compiler stopping you from doing stuff.
What I found surprising in Python, then they actually have a notion of a class, at least it looks like. So I found some Python code with class in it. It's like, this is strange, because, they said, years ago, there was like, Java is object-oriented, and this is a bad idea, and functional code, we don't need any classes. And in some Python code, I found classes. Like, this is strange, because it seems like it was not that popular, this concept, right?
Yeah. I think most of the Python code I've seen does have classes, but it's a bit more like, I guess a bit like C++ in that you have classes, but you can also have like lots of global stuff which lives on its own.
Yes, you can do this in Java as well, right? You have a main method with static and just start create classes if you like. It'd be strange, but it could work. Okay, but back to agent, which is an interesting concept. So an agent has what it has. It is a process which runs somewhere. I would say similar to a microservice. And the first thing you would do, you would expose an agent card, right?
Yeah. So when you write an A2A application, the two things you need are the agent card, which advertises what it does. So it says which of the three protocols that are part of the spec are supported, has like a description of the capabilities.
In plain text.
Yeah. So, actually, it's like the agent card is in JSON, but
yeah, exactly.
But the description stuff is in plain text. Yeah.
So, and in Quarkus, I assume there's an annotation, right? So you can say this is the
right. So this is like two parts, really. Like so. I mean, the SDK is like an SDK. This should be usable by anybody, right? So there's people working on integrating it with Spring. We have it integrated in Wildfly somewhere else. The reference invitation in the SDK does Quarkus, but we don't really want to add all the bells and whistles for Quarkus in the SDK because it should be like sort of a bit neutral. We're just using Quarkus as a reference. So the Quarkus AI team are looking at closer integration with Quarkus because like the SDK is like a bit low level. You configure everything with builders and so on. But of course in Quarkus they will want to use annotations as well. And also the client that you use to connect out from your agent to other agents, that's also quite manually configured, but you can see that.
But there's like a qualifier like annotations called public agent card, so you can publish an agent, right? Card.
Yeah, or this is like actually more internal in the SDK because the SDK is wired together with CDI. But I guess in Quarkus they'd probably replace that bean with something else which understands some kind of configuration. But it's just like a wild guess. Don't take my word for it.
But from the SDK, I'm on GitHub right now. So there is the agent card comprises weather agent. This is the name. The name, the description, then the URL version. And capabilities is a little bit more interesting. So there's whether it supports streaming and whether it supports push notifications, state transition history, and input and output, whether it's text or something else, and some text and examples, which I think there are examples, but I assume they are very important. Because this is the hint to other agents what can be done, and the protocol version, the current protocol version, and also which protocols to pick, and this is like this is a JSON document, and the other agents, if they read the agent card, will decide whether they will call this agent or not, right?
Yeah. So it's a bit like MCP, which
Mhm.
we kind of see as different. So basically, MCP like standardizes how an agent or an LLM accesses tools,
Mhm.
and that also like gives some capabilities and stuff,
Mhm.
like which tool should I use.
Mhm.
So, but like a tool we see as like more simple, like it's kind of stateless, more like a function call, whereas
Mhm.
an agent is more like a proper LLM system, which has conversation history and so on. And it can use tools, but it can also use other agents.
Mhm.
So from the capabilities advertised by the other agents,
Mhm.
it figures out which one it should use.
Mhm. So agent is like a process and tool is just like a function, more or less. It's like a connector.
Yeah,
So
that's at least our interpretation. I don't want to upset
yeah.
anybody who loves MCP, but this is like our
Mhm.
take on it. Yeah.
Yeah. So for maybe MCP would be like JDBC and the agent would be like Quarkus, which exposes JDBC. It already runs and waits for calls, right?
Yeah, yeah.
Mhm. And A2A is interesting part because this is actually peer-to-peer. So the agents can communicate back and forth. So it's not like REST where one agent can call the other agent. You are calling the other agent and you can wait for response and the response can be streamed to the other agent, right? Which I
Yeah.
assume could be challenging to implement, right?
Yeah, if you're going to roll this yourself and then
Mhm.
every agent speaks a different language, then you've got a big job.
Yeah, exactly. But which protocols is Quarkus supporting?
We support all the SDK
Mhm.
protocols. So they are JSON RPC. So actually, the first version of the spec that we supported, like I don't remember the exact number, but
Mhm.
it was all based around JSON RPC.
Mhm.
So you have like this request wrapper, which has like the JSON RPC version, the name of the method you want to call, and then the payload.
Mhm.
And then the response like has some similar wrapping. Then in the next version of the spec, which was probably 0.30, they introduced HTTP plus JSON, which is basically REST.
Mhm.
So for JSON RPC, there's like just one endpoint.
Mhm.
Well, for REST, there's like one endpoint per method
Mhm.
that the SDK supports. And then the last protocol is gRPC.
Mhm.
And they've recently standardized because gRPC is defined with like a proto file,
Mhm.
and then the other specs were defined with like some kind of JSON definition. Um, so then recently, now for the upcoming 1.0 spec, the A2A proto is like the master thing, and then everything else kind of like generated off this. So there's like one source of truth.
Mhm. Okay. And and this is why we need the agent card because it advertises so okay I'm just supporting gRPC or JSON RPC or whatever, right?
Yeah, exactly,
Mhm.
yeah. And then the client then also has like, this is not really defined in the spec, but our client in A2A Java basically has, or I'll go a bit back. Like once we had all this, we first wrote the client for JSON RPC,
Mhm.
and then these other two protocols came along, and then we ended up with like three clients which all looked slightly different
Mhm.
depending on which protocol you want to
Mhm.
call. So we created like a higher level client, which then delegates to this more protocol specific clients under the hood. So
Mhm.
the client looks the same no matter which kind of
Yeah, this is
protocol
like
you're
a
interacting
facade
with.
to different protocols, right? Like an adapter.
Yeah, yeah.
Mhm. And there's also a notion of the agent executor, which is an interface, and you have to implement the interface, and you get two parameters: request context and event queue. And then you have to do something inside, right? And I guess this is when one agent calls the other agent, right?
Yeah, so this is like so I said earlier, like you write two things when you write an A2A implementation. One is the agent card, and then the other thing is the agent executor, which you mentioned. So yeah, that's where you do the work. So you get the request context and then the event queue. So the request context contains the message sent from the client.
And the client is typically another agent.
There's like two levels really. Like there's like requests coming from the user come into like what I think the terminology is like the client agent for the whole system. And then
this is usually if you do proper agentic system, this would be like a supervisor or the coordinator, orchestrator, or whatever.
Yeah. And then so its stuff coming in will be from the user. But then that calls to other agents, and then their stuff will be from the host or coordinator agent, whatever their input is.
But an agent actually doesn't know whether it was called by user or by agent, right? This is the same invocation from outside.
Yeah. There's nothing marked there. I think I could be wrong, but like it should be agnostic because I mean, you could have like a weather agent being called by a user or by another agent, and it doesn't really care, I think, because its job is to find out what the weather is wherever you're asking. The request context also contains a few other things, but before doing that, it's probably worth separating the kind of two types of work that an agent would do. So, and that's like a foundational thing in the protocol as well. Like some messages or user input or agent input can be asked really easily, like what time is it, for example, and then you just send back a message and you're done. It's like a simple interaction. So the construct that we send back in this case is just a message. So there's no state, nothing. Then there's like other things which are more like multi-turn, long-lived stuff. So they end up being tasks. So when a message comes in, it will the framework before it ends up in execute will check if there is a task already for this. On the first call to the agent executor, there will not be. But then the agent executor is like, okay, this is like something which I can't answer in one go. So let me create a task and put this on the event queue, which in the background will create a task in the task store.
So the task is bound to the conversation, right? So this is stateful.
Yeah, this is like a kind of like a bit like a conversation context. So then this, so there's like a task ID and a context ID used to identify this on the protocol level. So after the first interaction, you place this task on the event queue, which ended up storing it, and then you return back to the user the task ID. Actually, return the task or a task update event. It depends a bit. It's really up to the executor exactly how to do this, but the client should be able to figure it out from this. But anyway, then the next call coming in, the client will use the task ID it got assigned. The framework will look up the task, and now the request context will contain the task. And then the task basically contains like messages which are user input or agent input, like whatever was sent to this agent. And then the executor probably will do some work with an LLM and other tools and things like this, maybe other agents. And then the results of that basically get appended to the task as artifacts. So you have like a history of the inputs and the outputs for the whole conversation.
And what is a task in Java? Is it like Java record?
Yeah, it's just a Java record. Yeah.
And
we had like lots of a mixture in our spec API, but we're working now in the upcoming 1.0 release, for which we just released an alpha this week actually. But we standardized on records now for all the
very
API
good.
classes that the user deals with.
And I'm just looking at the spec, and there is even a JSON schema defined for the entire protocol.
Yeah, so that's generated from the proto file now.
Okay. And there are requests. Exactly. So it means the tasks contains messages, right? And messages can have different types or parts.
Yeah, so there's like text part, which is text input, data part, which is like more like binary data, and then file parts, which like reference some file either by its path or URI or actually the contents of the file.
I'm just curious about the Java doc. And it should be, and there is A2A. There are development guidelines and official. We'll put to the show notes. And there's a Java example. Exactly. And there is a task. Okay. So we have how this works. We talk about the context, request context, which may or may not contain a task. And I guess there's only one task, which can have multiple messages, right?
Yeah, so it's kind of like the conversation history, I think, for this current job that the agent's trying to solve.
Okay, exactly. So if there is no task, a task is going to be started, and if there is a task, there is a session, and at the task we have the messages, and the messages are important because so far what we actually built is just two processes which are able to extend messages and or messages to two bots which communicate with each other, and they remember what they said because they were able to put the messages on the task, which is contained or referenced by a request context. Yeah. And now the question: why there are two parameters, request context and event queue? Why the event queue is not on the context?
That's a good question. So basically, it's probably a bit by chance. So when we started working on the initial implementation, the Python implementation was already working, and that was the only implementation. So, and it was evolving really fast. Like every day, they'd have rewritten it. So we were kind of basically just kind of trying to copy quickly what they had done in Python in Java and Javaizing it a bit. So this event queue just is in that interface because that's how the Python thing was ready.
And does the event queue contain the messages?
No. So it's like it's basically like a task store.
Task store.
Yeah. So when a message comes in, we look up in the task store to kind of see if there is a task, then put that in the request context. Also, yeah, this is like going to be a bit of a tangent, but since tasks are like long running, Users can like get information about about the state of their task in 3 ways. Like one is polling, which hits the task store and then checks what's the current state of the task. The other one is streaming, so you get like SSE events whenever the task is updated. And the final one is push notifications. So when the task is updated, it will do like sort of a webhook thing to whatever you specified. So basically, the agent executor runs in its own thread, in a background thread. So when it does work in the task, its work updates the task. This gets put on the event queue, like either the new task you've created, if there wasn't one, or if you've updated the status, or if you have appended some artifacts, then this gets put on the queue, and then this updates the task store, basically. So it's just like an internal plumbing thing.
So the event queue, I can put to event queue a task.
Yeah.
Or whatever I like. So I don't see the
Yeah, or if you just want to return a simple message, just put the message on the queue. But yeah, you basically just put the new stuff on the queue, and then it gets stored in.
And the event queue
background,
gets stored,
and then like if it's a blocking send message operation, that will like wait for something to come out the other end through the queues in the task store. And then
so what is the purpose of the event queue? Is this like I can send messages immediately to the other agent, or is the event queue storing?
It's just internal stuff, really.
Because this is curious why we need this. I take a look at the examples, and this is not. So I have a task updater, and it has a context and event queue. And this is basically it. So in the method execute, there is no further reference to the queue. Cancel also seems not to use the event queue. So it would be interesting to know, what is the...
when creating the task updater, I'll just double check. If you see the task updater constructor, that takes the request context and the event queue.
Yeah. This is what I see in the code. So the task updater does something with it, right?
Yeah, so that puts the stuff on the queue ready. So now that you point this out, maybe we shouldn't put the event queue in this interface and just give them the task updater.
Okay.
I like to note that down.
Very cool. So, do you have Java doc of the SDK somewhere online?
It's not published. For the previous versions of the protocol, Java doc wasn't really that great. But like I mentioned, like the 1.0 spec is coming out now, so that's like the first proper version. So now we have proper Java doc for the spec classes the user deals with, like task, message, data parts, etc., and the client APIs and the integration point APIs on the server. So yes, it's much better now, and we have an issue to find out how to publish it somewhere on
Yeah, I believe
the A2A site.
You need a web server or something.
Yeah, I think we probably want to put it on the central A2A protocol org website somehow.
The task updater is a part of the example, right? It is not part of the spec. So I just opened the spec because I was curious.
Yeah, it's like a utility class that we created.
And some classes are starting with A2A and the others don't. So we have like A2A error, but we also have data part, which doesn't start with A2A. Is it like an important distinction?
This is in the spec package.
I'm now in IO A2A spec.
Yeah. Right. So the ones which, again, I think this is like a bit sort of historic by chance.
Mm-hmm.
But basically, a lot of the A2A ones are like, they're like exception things, and they're
Mm-hmm.
like sort of base classes for the concrete error classes that are mentioned in the spec, if that makes sense.
Mm-hmm.
So they're kind of like more like abstract base classes, I'd say. Or not really abstract, but base classes.
Okay. And we have the distinction between IO A2A spec, and then there is server, IO A2A server. So you know why there are two packages. One is called spec, and the other one is server. You remember this?
Which class is in server?
Server was the updater, the event queue, for instance.
Oh, okay. So spec basically is stuff that's in the spec, like task message, agent card, blah blah blah. So so that's like stuff the user would interact with from the client. The server stuff is like the stuff you deal with to implement the server part of the agent.
But interestingly, it's still in IO A2A. So it seems like it is the same namespace.
Yeah, we use IO A2A for everything.
For everything, okay. So IO server is not the spec, which means this makes more sense, but it also means that event queue and task updater are not part of the spec.
No, they're like server implementation stuff.
Which means agent executor. Ah, okay, now I see. The agent executor is also not part of the spec. It is request context also not. So it means the spec only comprises the protocol. Seems like, you know, this is the A2A protocol. These are the on the wire protocol, and the surrounding things, is the SDK, but are not part of the wire protocol.
So
you know what I mean? So this is the distinction.
so the server side, I guess we could have written whatever we liked as long as we served the protocol. But we did kind of like stick with the Python implementation in the beginning phases. So we stole these ideas from there basically. And since it was like moving so fast in the beginning, it made a lot of sense because we could see what had changed and then quite easily port the changes to our side.
Now I understand better. So it seems like the original protocol now exactly there is server common, and now we will find the tasks class, and there is a task updater now. So we see the task updater. Okay. So, but this is it means Google cares just about the wire protocol, which makes sense. And so it can be interoperable between agents. And I think the origin spec doesn't care a lot what happens inside, right? So this is what the event queue and request context are implementation details of the server and not part of the spec, I would assume.
Yeah. So that's probably like more like a SDK thing than a spec thing. But I think it's good to like sort of keep these constructs similar to the Python stuff because people can write these agents with A2A in any language they like. So they might start off on Python and then find out that we need like enterprise Java stuff. So maybe we translate this agent into Java. And then it's good to like have some kind of similar constructs, I think, to make that easier.
Yeah, because we can share patterns or best practices or whatever, right? So exchange idea is easier.
Yeah, I haven't looked at the other language implementations, but I'd sort of like guess that they probably do the same. But but I've not looked, so it's just a guess.
Exactly. And what's interesting, I opened the event queue because I was interested what's inside or what can be passed. And this is an event queue item, which is stored. And the event queue item has an event, and the event is spec event. Okay, so the event queue contains events.
I'm actually rewriting this at the moment, but
very good. So,
but it still will look the same.
Oh, you are rewriting, and it won't change. This is.
It's a big change.
We change, okay.
It's probably like a bit too technical for a radio show, but like you have the clients sending messages or streaming the same task.
Mm-hmm.
So at the moment we realize that. So then they subscribe to the queues. And when events come in, that's when the task store gets updated.
Mm-hmm.
But that means if there are two clients streaming stuff from the same class, the task store gets updated twice.
Mm-hmm.
So I'm kind of putting a central event bus processor before propagating the events to these listeners.
Mm-hmm.
But then we have some additional stuff on top of the spec as well. I don't know if it's a good time to mention it, but basically all the SDK stuff, like the task store, the store push notification where they should be sent to, and the queue manager, they're all in memory, so they don't survive server reboot, and they won't really work in a Kubernetes environment. You have lots of pods serving the same microservice or the same agent. Mm-hmm. So we have some database versions of the task and push notification store. And for the queue manager, we have a replicated one, which uses microprofile reactive messaging, and we have a test with Kafka. Mm-hmm. So when you put stuff on this event queue, then it basically gets propagated to the other agents, kind of serving the same application.
Mm-hmm. This is what I suspected is a communication protocol. And I took a look at the event, which is a marker interface, and it is implemented could be implemented by task on other events. What I think what you could do is, the event could be a sealed interface, right? Because we know which implementations are in the spec. So it will help you with all the switch cases later. So I think the event can be a sealed interface. But this was just an initial idea. But from the implementation perspective, so we have events, which is just nothing. It's just marker interface. And then one implementation is tasks we talk about. So you can put the task as an event to event queue. And what it says right now, the event queue gets automatically replicated. What I think is optional, but was really important, that the event queue gets stored somewhere, right? Because the agent could come and go, and the entire conversation and everything has to be there, has to be persisted. Because otherwise, we cannot say the Quarkus will know. It's a highly available process which run day and night. It could be a serverless process. So it is important that the entire context is stored somewhere, right?
Yes, that's actually the task store.
Mm-hmm.
So basically, at least with the rewrite I'm doing, before replicating the event to the other nodes in the cluster, it will store it in the store first.
Mm-hmm. And the task store is the best interface so far. It's very simple. It's save task, get task for task ID, then delete task and list. And you get list tasks result. So it is like CRUD interface, which can be implemented by various storage.
Yeah.
And
These like additional improved stores and stuff. They're in the extras folder
Mhm.
of the SDK.
Okay, what we didn't talk about is LLMs at all. So right now we implemented a pretty cool communication vehicle where two processes can talk to each other, store their conversation, the history somewhere, and even stream. So what we could implement with this, just let's say a backup system, right? We could have one agent which, without any LLMs, just back up something in the cloud and sends back to the client which files were stored, right? This would be an absolute valid agent-to-agent communication without any LLMs involved. This was agent-to-agent without any AI, right?
Yeah. And to be honest, most of the most of the tests and stuff we work on are like LLM less.
Yeah, well, because why
Protocol.
LLM? It doesn't matter for the test at all, except you sleep for 5 seconds. So now if you're realistic, because
Yeah.
LLMs are slow, so you have to be able to wait. You have to be patient with LLMs. But yeah, you're right. Okay, so but now LLMs come into the picture, and why we do all the tasks and events, because from the entire thing which we talk about, we need actually a string, which is the prompt which has to be sent to LLMs. So the entire ceremony so far is only necessary to have enough information to create a prompt which is relevant, and the prompt must not be too long. So it is, it has to be just the right size for the model. So it means usually what we will do is we use LangChain4j, for instance, inject the LLM, and then use the information from the agent. This would be the messages, whatever we have, and ask the LLM to do something for us, right?
Yeah.
Is there any support in the A2A, for that? That give me all the messages? No, yeah, this is absolutely LLM agnostic. It's just say this is the message. Here's the information, and do whatever you like.
Yeah. So yeah, that's more or less it. And the task basically contains the full context. So so if you want to call another agent, you could probably inspect the task, find the relevant data for the call to the other agent, maybe provide some of the answers that are relevant as well, and then send that over to the other agent, and then get the answer back and append to your artifacts in your task.
Exactly. So if we would implement like summarization agent for the conversation right now, we would get, the messages, what I ask you, what is the event queue, what is the request context, whatever. There will be the individual text messages with my questions and your answers. And we would have to go to the task store or to request context, get the task, ask the task for all messages, then ask the messages for the content, which is text part, I think. And then we will have to create a multi-line string with the information, send to LLM, say summarize the conversation, then we get the summarization, and the result would be the summarization, right?
Yeah.
And is there any object for the result? So we have the task, but if the task is done, in the spec, whether there is a specific entity which says, okay, this is now the answer, or is just an event and message?
Sorry, I got a bit lost there.
If we get the summarization back, so we are done as an agent. So we say, so you will send, the answer, the result, the response back to the client. Is this just a regular message, or there is a specific type of an object?
Since this was already a task, like it was a bit long running, so this will get appended to the task's artifacts. So it would be like the last artifact that's
okay.
The text.
Nothing special with it. Now, what's interesting, always interesting, I think, is to know when the agent is done, right? So because the agent is in a loop, it just, it gets an event, it does something, or even it gets a task. Let's say backup this folder. So now, okay, then this is easy because there's no LLM involved. It knows when it's done, when the folder is backupped. But let's say in other cases, it's not that easy to tell. For instance, the question would be, explain me A2A, for instance, right? So this, the agent will have to decide, is the web search or is the spec search or whatever. And when the agent is done is when the concept is found. So it means we need a decision, Are you done? Do you already know what A2A means? So we need kind of a loop which calls the LLM over and over again with different prompt or with modified prompt. And then someone has to decide when the entire thing is done. And I guess this is the job of the supervisor agent, right?
That's a good question, actually, which I've not really thought about. But so there's like a task state which is in the task, and that's really set by the agent executor, so like the agent itself. So that really is the one who says it's final. So it kind of seems like it decides itself in this case, which is interesting. The only thing...
it is. I think it is right because the agents are on multiple level. There's one, the supervisor agent is done when all sub agents are done, or at least the supervisor has enough information to satisfy the user, and the sub agent is done whether the subtask is done, right? So this is But what's really interesting is the agentic loop. If the agent autonomously does something, web search, whatever, then the sub agent has to decide when the answer is good enough.
Yeah. So, I don't really know the answer to this.
Yeah, it's just thinking about the agentic loops, and
also if it doesn't mark itself as final, you could always cancel it from the calling process.
What's also interesting to make it a bit more complicated, we have MCP. So what it means is the MCP would mean that actually MCPs, my perspective, are actually built for clients because the clients calls the MCP and it gets the tools. So LLMs do not directly understand MCP. They just understanding the tools. So it means the agent will have to understand the MCP protocol or the client, like ChatGPT or whatever, because the MCP, you go to MCP and say, give me the tools, give me the prompts, and give me the resources. So this is more like UI feature, almost MCP, right? And the agent are more about the tools inside the MCP, right?
Yeah. So I think like if we have our agent and it supports and it uses LangChain4j, then if it's using MCP, then LangChain4j has some annotations and things, I think, which tells it which MCPs or which tools and MCP servers it has available. And then it does some magic when you call your LLM.
Yeah, and imagine by calling LLM is just, telling the LLM this is these are the tools available with description. That's all. And MCP is like a wrapper around that.
And I guess that if you were to have your agent also calling other agents, then maybe like, I don't think this is implemented in LangChain4j yet, but maybe that would also get registered as kind of a tool. And then, but it would take longer than a tool call, but it probably has to kind of adapt to calling the other LLM for you.
You mean you could have an MCP which is agent call, right?
Yeah, something like this.
Yeah, absolutely. You can have you could have a tool which is an agent behind the scenes. You can have MCP which is agent behind the scenes, and you can just use the client, the agent client, right, to call the agent.
Yeah.
It is actually trivial stuff, but there are too many words or concepts which basically are nothing else than big string concatenation at the end, which sends the string to LLM, and you get the answer. This is basically what happens. And maybe one interesting, I think this outside the spec as well. There's nothing about memory, right? In the implementation, it's just the agent to agent, but memory is out of scope.
Yeah, well, I'm not totally sure what memory is, but like the task really, is that the memory?
There are two memories usually. There's a short-term and long-term memory, and this is the agent can persist stuff. So I guess that the task store is maybe it's the abstraction of the memory. Google way to note, because if you take a look at various agents implementations, they always have a memory. And what you do with the memory, and there are even LangChain4j and Quarkus without A2A. So just if you take a look at the Quarkus with LangChain4j, they also have a notion of memory. And what they do with the memory is you have it's almost like a cache, so they can discard all the items. You can get because what you don't like is to have the conversation too long, because if you have
exactly.
too much stuff, it doesn't hurt us, but it does hurt the quality of the LLM, because if the prompt becomes too big, the results are less precise.
Yeah, so the spec really saves everything in the task.
Mm-hmm.
Then I guess it would be up to the application you write using the SDK to kind of maybe trim down how much of this you want. So you basically like clone the task and replace the memory with whatever you like.
So now it's an interesting relation between you and the other teams, because I think what happens, what you are doing, you're building, the reference implementation, which is simple, and then Quarkus will take over, and maybe you will have, task store, which is Hibernate backed with all the, additional features like, long-term and short-lived memory and stuff like that. This would be the Quarkus added value. Right now, there's just Quarkus used as a runtime for the bare reference implementation, right?
Yeah, so it'll be stuff like this, and also probably like more injectable stuff rather than having to like use builders to create everything you need.
But I also like the builders. Actually, the spec right now looks nice.
Oh, good.
Yeah, this is like simple, and for me it was not obvious, but now it is. A2A spec is the wire spec, and everything in A2A which is not .spec, like server and so forth, is just the implementation of the reference. This is the reference implementation, right? So this is the distinction. Mm-hmm.
Yeah.
So maybe more explicit API and SPI segregation would be. This was not obvious at the first glance, but now it is for me.
Yeah, that's a good point. So I'll note them down.
Sorry to generating work for you. This is the podcast should be fun and not create new tasks.
Yeah, well, I'm grown up, so it's okay.
Perfect. Did we miss something, or we covered the most important A2A concepts?
There's one more thing which I don't really know anything about, but it's still quite interesting. So that it also supports extensions.
Mm-hmm.
So there are like some. Farah started one of these before she left for another company, but there's like the agent payment protocol and other things like this. So they build kind of on top of A2A, so it's quite flexible. And for example, agent payment protocol, I believe, is like that. You can like monetize agents and
okay. This is like the payment.
Yeah.
The payment RFC agent. This is fun.
And there's something like a GUI thing, which I have no idea, but it's in our in order to do this. So
And the GUI is also interesting. What the GUI is, it returns a snippet of the GUI which can be included. So it is actually a big thing. What you could do, you could use the Quarkus template engine, for instance, to create a snippet of HTML, which will be returned to the UI and will be displayed. Because right now, agents are not able to generate the UI. Okay, these are the extensions of the protocol.
yeah, so once we get the 1.0 out of the way, then I think picking up on some of these extensions will be
UI, I think, is the most interesting for you because you have already a template engine in Quarkus. So this would be an interesting one. And the agent payments protocol, this is what you mentioned before.
Yeah.
Maybe the last thing.
Half done.
Sorry?
Oh, the payment protocol is like half done, but again, this is Farah who started it, so we've not had time to pick up on it.
Maybe last thing, which is an enterprise thing, authentication and authorization is also interesting, right?
Yeah, so the spec does authentication, or well, I don't think it. Actually, I'm really woolly on security. I always make somebody else do it, but I think authentication is kind of part of the spec, like from the web standards. We have been talking internally that authorization isn't really mentioned at all, and but we don't really know how people will authorize stuff. But we think we at least need like some hooks somewhere. We know we're like around the default request handler to sort of handle which tasks a user wants to work on, and then at least have a hook for people to implement their own checking stuff, so they can see if a user Kabir is allowed to look at task number 3, or if that task number 3 was created by Adam, who doesn't want Kabir to see it.
Authentication. So what's interested is we had out of band credential acquisitions. It says OAuth 2.0 tokens. Header transmission. This would be like bearer token has to be supported on API keys. And server-side validation should be in place. But it looks like basic, web security, what we get.
Yeah. Actually, Jeff Menil is working on something to do with security at the moment. And improving the TCK to do some tests for security. There's also another thing worth mentioning, like the agent card comes like in 2 formats. It's like the agent card that's open to the world. But then once you're authenticated, you get it used to be called extended agent card. I think now it might be called authenticated agent card. I'm not really sure. But that will potentially contain more information than the raw agent card.
Pretty cool. So we covered a lot with A2A. And you still like the agent, right? Or you need some vacations? Agentless vacation.
No, this is a good, fun project to work on.
Okay, cool. Where people can find you?
Right, so I'm normally in the Wildflies ULIP because that's my other main job. We're also in Discord for the A2A stuff, but I don't know the link. There should be one somewhere.
You sent me and I put it to the show notes?
Yeah, I'll do that, yeah.
Very good.
Yeah, that Discord's probably the best if you want to talk about it.
Yeah, and your name is Kabir Khan?
Yeah.
So
Khan.
People can just, search for A2A Kabir and will find, that you are very eager committing on GitHub.
Yeah.
Was fun to talk with you, chat with you again about A2A Quarkus and the reference implementation.
Yeah, I've had a good time. Thank you.
Thank you a lot.
Thanks.